All right, so we are going to wrap up section 1.3 today and continue our discussion about complex numbers and how they work. So in the last video, we looked at just the imaginary unit and what it meant for I to get involved with mathematics. So anytime you ran into a square root of a negative number, we usually broke off the square root of -1 and we got the value of I. Now we're going to learn how those I or those imaginary units mix in with an overall complex number. So from our definition here, a complex number is a number that can be written in the following form. So we will write all of our complex numbers in the form A plus BI. Now, that formula is a little bit misleading in that you can have negative numbers. So the general form looks positive, but it's okay if you get some negative values. All right. The other thing to note, and I don't know if we'll ever run into this very much right now, but if we ever run into the value of Z, Z is usually our representation that I want you to find a complex number. So that may show up once in a while, and I'll try to remind you in our videos what that is as we deal with it. As far as breaking down the parts, since there are two letters involved with every complex number, do be aware that the A part is what we're going to call the real part of our complex number, because you notice A does not have the imaginary unit. And since B has the imaginary unit attached to it, we're going to let B be called the imaginary part of a complex number. So a complex number always has two parts, the real part and the imaginary part. And so what I want to do is I want to work some problems of how we will work with complex numbers in this class. So beginning with the basics, how do you add and subtract complex numbers? Well, the good thing is you don't do it much differently than you do regular numbers, except you're going to have real parts and imaginary parts you have to deal with separately. So on this first one, where you've got 5 minus 3i plus -9 plus 7i, in order to work this, if you were to take this plus sign and multiply it through, the good news for us is that it doesn't change anything. You still get a -9 and you still get a positive 7i. And the only thing you have to do now is combine the common parts. 5 and -9 go together to give you -4. And then -3i and positive 7i go together for positive 4i. That is how you add complex numbers together. Very straightforward, but it's something you still got to be able to do. For number 8, what if you have 12 minus 7i minus 8 plus 4i? The only difference here is that you're subtracting them. And so that means when you do multiply that negative through to the second parentheses, it will change some of your values. You're going to have 12 minus 7i, and then it becomes -8 and -4i. If you combine your like terms, the 12 and the -8 go together to give you a positive 4. And then the -7i and the -4i, if you put those together, you get a -11i. And that would be your simplified complex number. Now, while not often, we also sometimes run into problems that might have radicals or might do weird things with complex numbers. So I want to do one of those for you as well. On number 9, you've got the square root of 3 plus 5i, and you want to add to that 4 root 3 minus 5i. Well, just like number 7, even if you try to distribute that positive symbol through, what ends up happening is really nothing. A positive makes this a positive 4 root 3, and a positive times a negative still makes this a minus 5i. And then notice what happens. For the first time in this video, we are able to actually cancel the imaginary part of our complex numbers. The positive and -5i go away. So all you have to do now is put your two other terms together. And so if you take root 3 and you add 4 root 3's to that, that means you have 5 root 3's. And that would be your simplified number. It's actually not a complex number, though, because there's not an imaginary part. This is just a regular number which sometimes happens when we work with complex numbers together. The other thing you need to be comfortable doing is multiplying complex numbers together. So here's two examples of how you will do that. I want you to multiply these together, and then I want you to always write your final answer in the complex form, the a plus bi form. So on the first one, you're being asked to take 3i and multiply it by 7 plus 5i. Well, so from our algebra knowledge, we can take this 3i and distribute it to both terms inside the parentheses. So 3i times 7 would be 21i. 3i times 5i would be 15i squared. Now, you might recall from the previous video that anytime you run into an I squared term, there was a number I told y'all it's always going to equal, and that number is -1. So what you will have to do anytime you run into an I squared is replace it with its value of -1. Now, according to my formatting, I need to put the real part first. So write down the number that doesn't have the I. Well, that would be 15 times -1, which is -15. And then your I term will come second. So I would write positive 21i. That is your simplified complex number. So distribution works. You also need to remember your basic FOIL technique. So what if you multiply 2 minus I times 6 plus 3i? Well, what you will do is you'll go back and remember from previous classes your FOIL technique. So that means you will multiply your first terms together. 2 times 6 gives me 12. Your outside terms, 2 times 3i gives you 6i. Your inside terms, -i times 6 is -6i. And then your two last terms, -i times positive 3i would be -3i squared. Well, it looks like very nicely, I didn't mean for this to happen, but it's okay. Your two I terms in the middle are exact opposites, so I can cancel those. And so I will bring down my 12. And then once again, remember, anytime you run into an I squared term, you need to replace that with -1. And so this will give us 12. -3 times -1 is +3. And 12 plus 3 gives us 15. And so that would be your simplified answer for this FOIL technique. All right. Couple more multiplying problems. I just wrote these in a different way to make sure we reviewed how to do exponents with multiple terms. So on number 12, you're being asked to find 5 minus 2i all squared. Now, make sure you remember, you cannot distribute the squared term to both of these values because there is a subtraction involved. So you might have to remember that whenever you work a problem like this, you have to actually write it out in its most pure form. So we're going to write it out as 5 minus 2i times itself, which is 5 minus 2i. And from here, you can then once again use your FOIL technique to simplify this down as far as you can. So if I were to FOIL this, first terms, 5 times 5 is 25. Outer, 5 times -2i is -10i. Your inner is -2i times 5, which is also -10i. And then your last, -2i times -2i would be +4i squared. Well, on this one, if I go from left to right, I'll bring down the 25. And then you might notice we can combine these two I terms. So -10i minus 10 more is going to be -20i. And then once again, we ran into another I squared term, so I'll replace that with -1. This becomes 25 minus 20i minus 4. And your last step is to put the two numbers together. So 25 minus 4 is 21, and then I'll bring down the minus 20i. That is your simplified answer for number 12. You can also do this with square roots, so don't panic there. So let's make sure we work one out so you can kind of see how this works. Once again, you've got root 3 minus 5i that needs to be squared. So just like the last one, I am going to take the root 3 minus 5i, and I'm going to write it out as multiplying by itself. And then from here, I'm going to do my FOIL technique. So we are going to have your, let me write FOIL again. We're going to do first, outer, inner, last. So for your first, root 3 times root 3. Anytime you multiply a square root times itself, they just cancel, and that gives you 3. For your outer term, root 3 times negative 5i is negative 5i root 3, because those don't combine very nicely, so we'll just leave them alone. And you actually get the exact same thing on your inner. Negative 5i times root 3 is exactly that. Negative 5i root 3. For your last, negative 5i times negative 5i would be a positive 25i squared. Well, just like the one on the left, I'm going to bring down the 3. I'm going to notice that both of my terms in the middle can be combined because they both have the square root of 3's on them. So if I take negative 5i root 3 and subtract 5 more, you should get negative 10i root 3. And for the 4th time in a row, we ran into another I squared, so I'll replace that with negative 1. So this becomes 3 minus 10i root 3, and then 25 times negative 1 is negative 25. And your last step is to put those two numbers together without the I. So 3 minus 25 is negative 22. And then I'll bring down in this case, the minus 10i root 3. And so that would be the simplified answer of number 13. So hopefully now, after this short video, you now see how the imaginary units we covered in the last video now play into the idea of what a complex number is. And so throughout the rest of this class, we may run into these complex numbers. You just need to be comfortable, especially multiplying them, adding them, subtracting them, and multiplying by them. We don't do any division with complex numbers, so don't worry so much about that. But the other 3 things you need to be comfortable doing. All right, so I'll see you in the next video.